everyone, and welcome to this video series on the fundamentals of research. This series focuses on the building blocks or the foundation of research. In previous videos, I've gone over how to go from concepts to variables and what variables are and the different types of variables. In this video, I'll be going over the relationships between variables. And then in future videos, I'll be reviewing what theories are versus hypotheses. So as I mentioned, this is part 3 of the series going over relationships between variables. One way that we look at the relationships between variables outside of doing any statistical analyses is by graphing the relationship between two variables. I know when you hear the word graph, you think, oh my God, this is involving math and it's going to be really confusing, and I get that, but that's not what we'll be doing here in terms of very complicated mathematics. What I'll be showing you is how to sort of break it down so that it's math that we all understand, and it just involves calculating averages. Okay, so let's look at what that would look like. We start with our x-axis and then our y-axis, just like in any graphing situation. Whenever we graph the relationship between two variables, the independent variable always goes along the the x-axis, and the dependent variable goes along with the y-axis. And that's why in the previous video I mentioned how the independent variable is sometimes abbreviated with x while the dependent variable is abbreviated with y. Okay, so let's say that we're interested in the relationship between depression, and it's going to be measured on some sort of scale that goes from 0 to 16, and hours worked per day, which is measured on a different scale that goes from 1 to 8. We want to know if our independent variable depression affects the dependent variable or hours worked per day. Put in another way, we want to know if the hours worked per day by a person varies by the level of their depression or is dependent on their level of depression. Okay? So let's say I do a survey of several people, and one of those people is Phoebe. And Phoebe's depression level is a 6, and her average hours worked per day is 3. So what would that look like on the graph? Well, we would find the 6 for her depression level and the 3 for the hours worked per day on average. If we draw a line between those two numbers, we get this point. And this circle represents Phoebe. It represents her data. Now let's say I have another person in my survey, Mike. Now Mike's depression is at a 12, and his hours worked on average per day is 6. So if we were to graph that, then we would find the 12 and the 6 and the 2 points in between, and there's Mike. That's Mike's data. Okay? So that's all we're doing when we're graphing. We're just taking two numbers and finding where they are on the graph. Now, if I take away all those lines, we're left with these 2 points. And when you first look at it, you might be like, well, what are those 2 points doing there? But if you think about what I just went over, it makes sense that that's Phoebe and Mike's data. Okay, so then when I add another person, they might be at a 2 and a 2. And then another person might be at an 8 and somewhere between a 6 and a 7. In this case, I kind of misaligned that. Okay, so the next person is at a 10 and a 4 and so on. So all of these dots, they're just representing people and their 2 scores on depression and average number of hours working per day. Okay, now when we're trying to understand what all these dots mean, we actually don't really care about the individual scores. What we're really interested is in the average scores of the number of hours per day by depression. So what does that look like? I know, just bear with me, it'll make sense in a second, I promise. So I'm going to start fresh here with our graph, and I'm going to add even more people just so we can calculate these averages. Okay, so let's say we have a person here and their score is a 1 and a 1, right? That would be them. Let's call them Jose. And then Julia has a 1 and a 1 as well. Now, normally they would just be overlapping, but I'm just showing you a little offset so you can see that there's 2 people there, but both of them scored a 1 and a 1. And then we have another person, let's call him Mark. And Mark has a 2 and a 1. And so does Jane. And so does, I should have come up with names earlier. Let's see, Priscilla. I don't know. Okay. But then we have Victoria, and Victoria scored a 2 and a 2. And so did Olivia. Okay, so both Olivia and Priscilla are a 2 and a 2. Then we have Joaquin, and Joaquin scored a 2 and a 3. And then over here we have River, and River scored a 4 and a 2. And then we have Dustin. Dustin scored a 4 and a 3. Meanwhile, Elle scored a 4 and a 4. And Mike also scored a 4 and a 4. And so did Lucas. And so did Max. Now, over here we have Jack. And Jack scored a 4 and a 5. And here we have Iris, and Iris scored a 4 and a 6. And then all these other people, right? We've got Elizabeth and another Jane and Ho and Allison. Okay, these are all the people in my survey. Now, what do I do with all this? In order to calculate the average number of hours by depression score. Well, we start with the 0 point on our depression scale. And there's no people who scored anything that was a 0 and a 0. So we just leave that blank, or we'll use dashes to show that there's nothing there. For the number 1 on the depression scale, we have 2 people there. And both of them scored a 1 and a 1, right? So what would it look like mathematically? Well, we would just add 1 plus 1. We would get 2, and then 2 divided by the number of people, 2 equals 1. So the average score for people whose depression scale was a 1 was also a 1 on the hours scale, right? Which makes sense because they're all both 1s and 1s. But let's take a look at 2, which has a little bit more variability. And variability just means it varies. So here we have, let's see, 1, 2, 3, 4, 5, 6 people who all scored a 2 on the depression scale. And we want to know, for all these people who were 2s on the depression scale, what was their average number of hours worked per day? So how would that look? Well, we would just add up all those people's scores. So the first person, I don't remember his name, sorry person, they were a 1. The second person was also a 1, as was the third person. The fourth person scored a 2, as did the fifth person. The last person scored a 3. Now, if I add up all those numbers, I get a 10. I divide 10 by the number of people, in this case 6, and I get 1.67, and I round that up to 1.7. So what does this mean? It means the average score for everyone who was a 2 on the depression scale was a 1.7 on the hours scale, okay? Now 3 had nothing, right? No people were 3s. For the 4s, we have a lot more people. So what would this look like? Same thing, really. So we go through and we say, okay, the first person scored a 2 on the hour scale. The second person scored a 3. There was 4 people who scored a 4, 1 person who scored a 5, and another person who scored a 6. I add up all those, I get 32 to calculate the average. 32 divided by those 8 people is a 4. So I put a 4 down there. Now the 5 had no people, so that's going to be blank again. and then I'm just going to put in the averages for the rest. Now, how does this help me look to see what the relationship is between these two variables? Well, let's start with just sort of a cleaner version of what I just showed you. So here we have the average hours worked per day by depression. And what I'm going to do now is plot those averages onto the graph. So right now, all these dots represent individual people. But now I'm going to overlay the average hours. So here, we have the average hours for the people who scored a 1 on depression being a 1. So there's that average. For those who scored a 2 on depression, the average was 1.7. So that's where that dot is going to go between the 1 and the 2, the 1.7. And similar to 4, which was the average for the average number of hours worked per day by those who scored the depression as a 4. And here's the average for this one, and the average for that one, and that one, and that one, and that one, and that one. Okay? So what I've done here is just plot those average scores. What will help me see if there's a relationship is if I can plot a line that we say is the best fitting line, meaning that it's the one that represents all the averages the best way, okay? And you don't need to know what that best way is right now. And maybe you won't even need to know it for this class, but just know that this line represents all those average scores in the best way possible, okay? So what does this line tell us? Well, we see that as depression increases, meaning it's going up, right? Going from 0 all the way to 16, as the numbers increase, the hours worked actually increases as well. So this looks like there is a relationship, and that as depression increases, hours worked increases. That doesn't make a whole lot of sense, but this is what the data showed us, okay? Now, there are different types of relationships. The first is called a positive relationship. And this type of relationship is what we just looked at, where as scores on the independent variable increase, scores on the dependent variable increase as well. So they're both going in the same direction, up. But, and this is where it might get a little tricky, so please pay attention. A positive relationship can also be where as scores on the independent variable decrease, so they're going down instead of up, but the scores on the dependent variable are also decreasing. So they're going down as well. Now notice in both these cases, the two variables are going in the same direction. So it doesn't matter what that direction is. If they're going in the same direction, then that's a positive relationship. Something that when I was learning about this helped me was to think about my arms. Okay, so let me give you a visual of what that would look like. So I love the show Survivor, right? So I'm going to use Mr. Probst. You see his hands, they're both going up, right? So imagine his right hand is the independent variable and the left hand is the dependent variable. So they're both going up. They're both going in the same direction. Or alternatively, they're both going down. Both his hands are down. And I almost confused myself. Don't do that. That's also a positive relationship, right? Doesn't matter if the arms are up or the arms are down. Both arms in both cases are going in the same direction. So up or down, as long as both arms are the same, then that's a positive relationship. So let's remind ourselves what that would look like. So that's the positive relationship that we observed between depression and hours worked. As depression increased, hours worked also increased. Now, there's another type of relationship, which is what I almost said before when I caught myself, which is a negative relationship. In these scenarios, as scores on the independent variable increase, scores on the dependent variable decrease. So they're going in opposite directions. Okay. Similarly, it could be that as scores on the independent variable are decreasing, scores on the dependent variable are increasing. Okay. So notice that the arrows are pointing in opposite directions in both cases, right? So if we have Probst here, well, that would be one arm up and one arm down. It doesn't matter which arm. Okay, so they're going in opposite directions. If that's what we find via the graph, then that's a negative relationship. Okay, so in this case, as depression is increasing, hours worked is decreasing, which makes more sense, like, common sense wise, right? But notice they're going in different directions. And on a graph, that's what this would look like. Okay? There's another kind of relationship, which is no relationship. Okay? So that means that there is no relationship between the independent variable and the dependent variable. Whoops. What would that look like? As depression is increasing, nothing is happening to the hours. They stay the same, right? And that's what that would look like, a flat line. So the average score of hours worked is a 4 for all levels of depression. Now, there might be individual differences. Some people might have a 5, other people might have a 3, or what have you, but the average is coming out to be about 4 for all of them. And that means that there's no relationship. But it doesn't mean it has to be a 4 always in the middle there. It could be, the average could have been a 3 or a 6 or, a 2.5. It just doesn't matter. It just means that the averages are all about the same. Okay. Then the last kind of relationship is called a curvilinear relationship. And if you look at the word curvilinear, it has part of the word curve in there, right? So that's what it looks like. It's an actual curve that happens. So as scores on the independent variable increase, so going up, scores on the dependent variable decrease, but up to a certain point, and then they start to increase again, okay? Or as scores on the independent variable decrease, scores on the dependent variable increase up to a certain point, and then they start to decrease again, okay? Sadly, I couldn't find a picture of Probst with curvilinear arms, so you're just gonna have to go off of the graph, okay? So what would that look like in terms of a curvilinear relationship? Well, something like this. Okay, so what does this say? So we put it into words, right? What does this curved line tell us? It says that as depression is increasing, the hours worked also increases, but only up to a certain point. And then it starts to go down again. Okay, so this is one of the types of curves that can happen. Another type of curvilinear relationship looks like this. So it looks upside down compared to the previous one. But that's not the only difference here. So you notice I've changed the variables. Now the independent variable is dosage of medication, which is measured in milligrams, and depression, which is on the scale of 1 to 10, 10 being the highest depression. Well then, what does this say about the effect of medication on depression? Well, as dosage of medication is increasing, depression is decreasing, but only up to a certain point, and then it starts to go up again. So if we're thinking of this in terms of medication and its effects, then that's telling us there is a threshold effect happening, meaning that the medication is working on helping depression, but only up to about 95 milligrams. After that, it in fact makes depression get worse. Okay, so that's pretty much all I have to say about types of relationships. Here are the images that I used, and that is the end of part 1. Apparently I can't read. Part 3. Make sure you go to part 4, where I will be going over what is needed in order to conclude that there is actually a causal relationship between the independent and dependent variables. What do I mean by that? Well, you've all probably heard of the phrase association does not infer causation. And an association just means a relationship. It's another word for relationship. So just because we see a relationship, like in these graphs, it doesn't mean that the independent variable is causing the dependent variable. So depression is not necessarily causing the number of hours worked, even though we saw that there was actually a negative effect, a negative relationship via the made-up data. In order to say that depression is the one that's causing some differences in the number of hours worked, there are 3 criteria that have to be present, and I will go over those 3 next time. So that means you're just gonna have to wait. I know it's going to be so difficult, but I don't want to give any spoilers. So please make sure you go to that video. Thank you for watching. Please leave me a comment if you have a question, or email me, and I'll either see you here or in class. Thank you. Bye.